Welcome back to Solving Equations. We're going to be gradually choosing equations that are more and more complicated. So in this video, we're going to concentrate on equations that have variables on both the left side and the right side. My first two examples, and I think there'll be three examples, but my first two examples, I'll show you that one person might do this problem one way and another person might do the problem the other way. Here's the big deal. When you see you have variables on the left side of the equal sign and the right side of the equal sign, you have to make a decision on which side you want to move the variables. Because this variable over here, this 6x term, it is in love with this 9x term. They're destined to be together. So either 6x is going to travel over there, or 9x is going to travel over here. But they're going to get together. It's destiny. You have to decide which way you'd like them to go. I'm going to do this. I'm going to say the 6x is going to do the traveling. So how do you move a 6x? And remember, there's a positive sign out there. You subtract and you subtract, doing the same thing to each side. What's left over on the left-hand side is negative 10 and 3x plus 2 on the right. Notice how I'm keeping everything lined up. It's really going to be a good habit to help you out. My goal now that I have the variable just on one side is to get the x by itself. That means I get rid of the plus 2. I'm still trying to get x by itself. The 3 is attached by multiplication. Division kills multiplication. And I have an answer. But I could do this problem a different way. In this case, we said I want the 6x to travel over to meet the 9x. Let's change that up. Let's move the 9x and have it travel over to the 6x. 6x minus 9x is negative 3x. These two add to 0, that's why we did that. And so now I have a different looking equation than I did over here, but we're going to end up at the same answer, or math is broken. My goal is to get x by itself, get rid of the piece that's further away first. I add 10 to both sides. I almost have x by itself. The negative 3 is attached by multiplication. I will divide. Ding, 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 ding. Math is not broken after all. So whether I choose to make the 6x go over to the 9x's side or the 9x go over to the 6x's side, I'm going to get the same answer, provided I don't mess it up. Please don't be jealous of how neatly each step carries over, where I'm just recopying every single term. All right, I'm going to do these two different ways. Let's say the negative 10w is in love with the w and wants to head over there. On this side now remains only a 4. Remember, when you see just a variable, go ahead and put a coefficient of 1 in front of that if that's going to help you remember that there's a 1 there. Variables on both sides, one traveled over to the other. My goal is to get w by itself. Let's get rid of the 18 first. The opposite of minus 18 is plus. W is almost by itself. There's an 11 attached by multiplication. I will divide. And I got it. I'll bet the same thing will happen over here. W equals 2. But now instead of making the minus 10 travel, I'm going to make the w travel. That's a positive w. So I will subtract w. And this is negative 10 times w. You can also think of that as negative 10w. All right, I have only a minus 18 on this side. Over here, this negative w and this negative 10w go together to be a negative 11w. I copy down the 4. One thing you should notice as we're doing all these, anytime we move a term from one side to the other, it always matches up with its like term. In other words, when this 10w traveled over to this side, it wasn't interested in combining with the minus 18 because they're not like terms. It was interested in combining with the w. Same thing up here. When this 6x went over here, it was interested in pairing up with the 9x, not the 2. This is a like term to 6x because they have the same variable. So we have now moved this plus w over to the other side. My goal is to get w by itself. I have to move this 4. There's an implied positive sign there. Negative 11 is attached. I will divide. And as we expected, we get the same answer no matter which way we go, this way or this way. Let's do one more example on the other side. A fraction. That's all right. In this case, by the way, if you felt like it, 1/2 is the same as 0.5. So I could have done 0.5x minus 2 equals 3x plus 8. 0.5 is 1/2. But if you don't want to do that, don't do it. I'm going to move this 1/2x over to that side because I have variables on both sides. There's an implied positive sign there. So I subtract. Everything else is going to stay the same. 3 minus 1/2. That's 2.5. If you had $3 and you lost $0.50, you'd have $2.50 remaining. Now some people would want to change this 2.5x into 5/2x, and that's totally fine. I'm going to leave it at this for right now at least. I'm going to say if I want to get x by itself, I need to get rid of the plus 8. So I subtract 8. Now if I want to get x by itself, and I didn't want to move it and call it a 5/2x, what I could do is I could say, hey, this 2.5 is attached to the x by multiplication, so I will divide. And if you want to call that a 2.5, that's fine. Those would reduce, although it looks very messy, doesn't it? A negative divided by a positive is a negative, and a 10 divided by 2.5 is a 4. I'm going to show you what would happen if you decided to take 2.5x and call it 5/2x. So I'm going to take that spot right there, and I'm going to say negative 10 equals 5/2x. This is equivalent to negative 10 equals 2.5x. And then you would go back to your fractions ideas. If I have a fraction attached to the variable, I will multiply by the reciprocal of that fraction on one side and the other. Because I multiply by reciprocals, cancel, 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 cancel. X equals, and now I would need to either go to the calculator or do mental math, and my mental math says that's negative 4. That's what's supposed to happen. Okay, this was equations with variables on both sides. Please, as you do this, line up your work as organized as humanly possible.